Okay, so we're going to be talking some more about finding the equation of lines. Actually, equations of lines. And before we get started, I do want to talk about the three tools we have. We've got three equations that are going to be essential for finding equations of lines. And the nice thing here is it's kind of built in what information you need. You always need two pieces of information anytime you want to find the equation of a line. You always are going to need a slope. And if you're not given a slope, it's one of the first things that we should know. So we'd have 2 points. And we'll designate one as point 1. So we've got x1 plus what? x1, y1, and x2, y, whoops, don't, my scribble here, x2, y2. If you're, now the other two are, if you're given a slope, you're already halfway to finding your equation. You've got our slope-intercept, by far the easiest thing that we can use to find the equation of a line. So if you're given a slope, m, and this and if your x value is 0, then this is, of course, the y-intercept. So if you're given the slope and the y-intercept, you're going to be able to just literally just plug it in and be done and find the equation of your line. Otherwise, you've got your point slope, and your point slope will, that takes a little bit more work, but it's also a relatively easy tool to use. So that's given any point and a slope. I would recommend that you actually memorize. These are three really, really good equations to memorize, because you will use these throughout algebra. And once you get into some higher math classes, once you get into like first year calculus, second year calculus, you're still going to use you're going to use these equations. You use them all over the place. Well, let's go through and I'm going to start with our easiest one to use to start off with. I'm going to start by finding some equations of lines given our slope and the y-intercept. I can actually spell y-intercept. So given our slope and our y-intercept, so if I've got something like, say I've got my first example here. Say I'm given that my slope is equal to 3/4, and I've got a point of 0, -2. All we're doing every single time is we're plugging in to y is equal to mx plus b. We're literally just plugging in these two pieces of information. So for this one, I would have y is equal to 3/4 x. Notice I'm not putting in 0 for x. I'm not putting in -2 for y. And b is equal to that -2, so -2. We're done right there. This is by far the easiest one to do. Now, I will say I've seen a lot of students make, they trip when they move from things that are this y-intercept to points that are not, and they'll just try to use this. That's wishful mathematics. That's not going to be as helpful. But yeah, we can do lots of these. These go really, really fast. I could do something like something where I've got slope is -1/2, and it goes through the y-axis at say 4. Okay. This is going to be, again, y is equal to mx plus b. Well, y is equal to, m is -1/2, In this case, it's going to be a plus 4. And we're done. Let's do it again. And I'll say that, yeah, let's do something. Oh, we could do something scary. I could, or actually even something similar or simpler, almost deceptively simple. Say I've got a slope of 2 and it's going through something like a 0, 1. Okay. Well, y is equal to mx plus b. Why do you think I'm writing this out every time? Might have something to do with repetition, helping you remember. No, y is equal to m is 2, x plus 1. And notice that I've seen people forget to put that x there. That's also very important. So this is by far the simplest type of equation to, or the simplest things we can do to find an equation. Let's move on to things that are a little bit tougher, where we're given a slope and a point. And in this case, we're going to use, unsurprisingly, our point slope form. This is y minus y1 is equal to m times x minus x1. And the things that we're going to plug in here are only the point. So this is the x1 and y1 are from the point, and the slope. So let's go ahead and give us an example here. Let's say that we have something like this, and I'm going to choose something that's going through -2, -5, and I've got a slope of 2. Okay, well, this is going to be y, and I've got minus this -5. My slope is 2, and it's x minus a -2. First thing that I like to do, oh, and something I should have done is always, I've been writing this out every time. Y minus y1 is equal to m times x minus x1. I like to say this every time so that way folks can memorize it. First thing I like to do with this, though, is let's resolve these signs. So I've got this minus a -5. That's the same thing as y plus 5. When I look at this, I've got minus a -2. I'll go ahead and make that a plus 2. And I can also distribute this. I'll have 2x plus 4. All right. And then last but not least, I'm going to I'll subtract 5 from both sides. So this way I've solved for y. We'll usually want our equation to be in this sort of format, that y equals mx plus b format. It's very, very useful. So yeah, let's do another one. Notice that, and we're going to do the same thing. One thing I want folks to notice is this y value here, that is not our intercept. Some folks try to just plug that in there. It doesn't work. Our y-intercept is, if I were to ask what our y-intercept is, I'd say, oh, it would be 0, -1. Let's do another one. And this time I'm going to do one that's a little bit tougher. I'm going to say, let's do something like, do another example here, and I'm going to have something like 2, -1, and my slope is going to be, my slope is 3/2. Oh my gosh. Fractional slope. What are we going to do? Well, panic is not one of our steps. Y minus y1 is equal to m times x minus x1. So again, let's just repeat that so we can hopefully remember it. And y, in this case it's going to be minus a negative 1, is equal to 3 halves times x minus 2. Well, let's resolve these signs. Minus a minus is a plus, so I've got y plus 1. Here, I'm going to just go ahead and distribute this 3 halves in there. So I've got 3 halves x minus, and think about what happens when I've got a whole number times a fraction. 3 halves times 2, this is the same thing as 3 halves times 2 over 1. And I can just reduce. 3 times 1 is 3 over 1. It's just, 3 over 1 is just equal to 3. So this is going to be minus 3. And now I can subtract 1 from both sides. And I will come up with this answer of y is equal to 3 halves x minus 4. That's a 2. I use this fat marker because well, it's wet erase and I can use it. I can reuse this paper over and over. But it's also nice and bold. But sometimes nice and bold means I want you to be able to distinguish my numbers. That's a 3 over 2. Okay, let's do some examples where I'm not given a slope, but I'm only given 2 points. And I'll do a couple of these. These are by far the most work-intensive questions to do. So let's say we're given 2 points. And if I'm given 2 points, and I'm going to start off with, and what we're going to use is we're first going to find our slope. And we use our slope formula. That's our y2 minus y1 over x2 minus x1. And then the next thing that we'll do is we're going to use that point slope formula, which is our y minus y1 is equal to m times x minus x1. So for example, let's say we've got something like a line that goes through our 2 points. I'm going to do 2, 4, and -3, -1. So the first thing that we're going to need to do is we're going to need to find our slope. Remember, our slope is this y2 minus y1 over x2 minus x1. I said it on this first page of notes. I want you guys to memorize these. So I'm going to keep repeating these. So our slope is going to be, well, y2, that's going to be -1 minus 4 over -3 minus 2. And in this case, it looks like I'm going to have -5 over -5. So my slope is just a 1. Well, that's nice. Now I'm going to plug into my point slope formula. This y minus y1 is equal to m times x minus x1. So from here, I could choose either of these points. I'm going to choose the one that doesn't have any negatives in it, just because I think that's going to be a little bit easier for us. So this is going to be y minus 4, there's my y1, is equal to 1 times x minus 2. So I've got y minus 4 is equal to, well, 1 times anything is just itself, so this is just going to stay x minus 2. I'll go ahead and add 4 to both sides. And I'll have y is equal to x plus 2. So I had a few more steps. I had to find that slope, and then we just used this formula to, once again, find our equation. And this is going to continue to do this every single time. I'm going to do one more example, and then I will set you loose on your own practice. I hope you've been taking notes and writing stuff, writing some of these down, or maybe even pausing the video and working these along with me. Let's do one more, and I might choose a slightly tougher one this time. Say we've got something like this. Let's do one that is through like -3, -5, and 3, 1. So let's see what this is going to look like. -3, -5, that's a 5. So remember, our slope is y2 minus y1 over x2 minus x1. So our slope here is going to be, that's a 1 minus a -5 over 3 minus a -3. Now, I guess this wasn't going to be too bad, because minus a negative, this is going to be the same thing as adding. So that's going to be 6 over 6. I thought I'd come up with a better one for us. So my slope is still 1. And once again, I'm going to go ahead and plug into our, this y minus y1 is equal to m times x minus x1. I think I might have been looking at my wrong list of examples, but I hope you'll forgive me if I give you an easier example. Y minus 1 is equal to 1 times x minus 3. I'll choose this point right here because, again, it's that one is positive, makes sorting out our signs a little bit easier. I'll have y minus 1 is equal to x minus 3, and add 1 to both sides. So over here on the left, I've got just my y left over. Over here on the right, I've got x minus 2, and we're done. All right. I hope if you have any questions, you shoot me a message, and I will see you in the next video.